Well, good morning. We're going to do a little bit of chemistry today, so let's have a look at some acids. Let's talk about our setup first. So I've got a strong acid and a strong base. The strong acid is HCl, and it's mixed so that they got about 1 mole of HCl for every liter of water. And the strong base is sodium hydroxide, NaOH, and it's mixed also so they got about 1 mole per liter of water. I've got some dilutions of acid and base. I've got some acid and base mixed with different amounts of water in these test tubes here. This large test tube has phenolphthalein. That's an indicator. Now, phenolphthalein is different colors because it's an indicator. It's different colors depending on what the pH is, depending on whether it is in an acid or a base solution. And then we've got a couple other indicators. I've got litmus. I've got some red and blue litmus. The red litmus, it looks kind of pink to me, and the blue looks kind of lavender or purple, but the names are red and blue litmus. And then we've got universal indicator, which is a mixture of several different indicators, and it changes color at a wide range of pHs. And instead of having just one or two different colors, it's got many different colors. And I've got some universal indicator that's in a liquid, and then I've got some universal indicator that's been added to paper so that I can handle it a little bit more easily. First, I want to look at universal indicator. And so universal indicator, got a little bit of paper with universal indicator on it. And let's see, if I add some acid, that universal indicator, which kind of starts out at a yellowish color, it's going to turn bright red. If I add some base, it's going to change a different color because it has a number of different chemicals. This guy's nice and blue or lavender color. So here's my scale that's indicating for me that my pH of my acid is about 0, so that's a very acidic solution. And the pH of my base is at least 13. By comparing it with that color, I can see that the pH is at least 13. Let's see about other solutions. I've mixed a little bit of acid with water. I've diluted that acid, and it changes the universal indicator paper to a different color, indicating that pH is around 2. And this guy, it's a little bit closer to neutral. It looks like the pH is around 4. This guy, this is just plain water. That's the color of the paper by itself. Gets a pH right around 7. Here's a tiny little bit of acid mixed with water. Excuse me, a tiny little bit of base mixed with water, getting a pH near around 8. And here is more base mixed with water, a more concentrated base. And there we're getting closer to our pH of 12 or 13. And here's another way of using universal indicator. This one is mixed in a liquid. It's an aqueous solution. If I put a drop into a liquid solution, it's going to change to a different color depending on the pH of that solution. Let's see, let's just mix these up a little bit. So the one on the left is the most acidic solution, and it turns the most reddish in color. This guy is slightly less acidic, more dilute solution. This one is nearly neutral solution, so it stays about a green color. And these guys are slightly less basic and slightly more basic solutions. So you can use universal indicator, which again is a mixture of several different color-changing chemicals that change color depending on it. And here's another indicator, phenolphthalein. Phenolphthalein is another indicator. So I've got some phenolphthalein that has a high pH. It has base already added to it, and it's a nice bright pink color, nice magenta color, or whatever you might call that. And I've got some phenolphthalein that I've added a little bit of acid to neutralize that acid. And in an acid solution, it is clear. Let me just show you that adding more acid doesn't change the pH. So I'm adding a couple drops of acid from my acid container. This is our strong acid, HCl, a fairly concentrated strong acid. A couple drops of that guy, indicate that we got a nice colorless solution. However, if we add base to our solution, here I'm adding a solution of sodium hydroxide, a strong base, a fairly concentrated solution of strong base. We get a nice, beautiful pink color. Let's see, as I mix it up, that phenolphthalein finds some more acid molecules and gets neutralized and goes back to our clear color. However, if I add enough base, to neutralize that acid, there's no more acid molecules to be found, and my phenolphthalein will eventually stay pink. As you can see, as I add more base, it's being slower at going back to the clear color. And with a couple more drops of base, now I've neutralized all that acid and made this guy a basic solution. Phenolphthalein is clear and pH is up to about 8, so acidic or neutral. Remember, neutral is 7. Acidic is anything lower than that. Or even a slightly basic solution, a little bit above 7, phenolphthalein is still a nice pink color. So when we have an acid, it will cancel out the effect of a base. That is an example of neutralization. So at first we neutralized our acid by adding base. Here I can add some acid back and neutralize our base as well. Just a couple drops there, and we neutralize our base. We undo its chemical effects. It's no longer able to turn phenolphthalein pink. If I add my base again, I can neutralize the acid and then have some base left over and allow the base to have the effect of turning that guy nice and pink. A drop of acid. Looks like there's just about equal amounts of acid and base here, so we have just a tiny little bit of pink color. One drop of acid neutralizes any base that's left over, gives us a nice clear color. We do about 3 drops of base. Neutralizes any acid that's there, and then we've got an unbalanced amount of base, enough to allow this base to make our phenolphthalein pink. Finally, I want to look at one more indicator. This is one of the earliest indicators that was found. It's a natural indicator. It's actually made by a kind of creature called a lichen. That's a plant-like creature that's made of fungus and an algae growing together. This litmus comes in 2 flavors normally. They call it red and blue, although to me it looks pink and purplish. And notice what happens if I add an acid to either the red or the blue. If I add an acid to either the red or the blue, they turn about the same color. They become red in acid. And if I add a base to either color, they turn about the same color. They turn blue in a base. So litmus is one of those indicators excuse me, that only comes in 2 colors. Kind of comes in a reddish color and a bluish color. No matter how it starts out, if you put it into a base solution, litmus will turn blue in a base. If you put it into an acidic solution, it'll turn red in an acidic solution, no matter what color it started out. However, if you've got an acid on litmus, you can actually neutralize that acid by adding a base and make the litmus that had just turned red, you can actually make that guy blue. You have to get enough base to neutralize that acid and then cancel out that acid's chemical effect. Excuse me, a little bit stuff in my throat. And then also produce the effect of a base. So acids and bases can neutralize each other, and indicators can visibly show that. All right, so I hope you know a little bit more about acids, bases, and indicators, and also about acid-base neutralization. So I want you to remember the name of our acid, hydrochloric acid, HCl, need to know its formula as well. Need to know the name of our base, sodium hydroxide, as well as its formula. I want you to remember the indicators. Phenolphthalein, that's the guy that is pink in a base and clear in an acid. And universal indicator, that's the guy that has that rainbow variety of colors. And here is our liquid version of our universal indicator, not the pink guy on the end, that's phenolphthalein, but these 5 guys in the middle. And I want us to know about neutralization, how acids and bases can cancel out one another's chemical effects. And we can see that by using indicators, either phenolphthalein, where we can go back and forth between clear and pink, or our litmus, where we can go back and forth between pink and blue.